All right, for all of us in the structural engineering field in India, the moment we've been waiting for is finally here. You know it, I know it. The seismic code we've all been designing to, IS 1893 Part 1 from 2016, has officially been revised. I've spent some time digging into the new 2025 version, and let me tell you, this is not just a minor update. We're not just talking about a few tweaked clauses. This is a fundamental overhaul that's going to change how we approach seismic design from the ground up. And that brings us to the most important question for every single one of us practicing engineers out there. Are your designs compliant? Look, getting up to speed on these changes isn't just good practice. It's absolutely essential for compliance, for public safety, and let's be honest, for our own professional liability. So let's get into it. Let's break down exactly what's different and what you need to do right now. So here's how we're going to tackle this. First, we'll cover the big philosophical shift behind the new standard. Then we'll dive into the brand new seismic map, see how structural response is being refined, check out the new rules for loads and detailing, and finally, I'll give you a practical checklist to update your entire workflow. Okay, let's start with the big picture. Because the core idea, the philosophy behind how we even define seismic risk, has completely changed. This is way more than just new zone factors. It's a total shift to a more modern, more data-driven way of thinking. This right here is the single most important change. We are officially moving on from a deterministic approach. You know, that old method was basically based on historical intensity scales. It was all about asking, what's the worst earthquake we've seen around here? Well, the new 2025 code is built on what's called a probabilistic earthquake hazard assessment, or PHA. What does that mean in plain English? It means we're now using complex statistical analysis of all known seismic sources to figure out the probability of a certain level of ground shaking. It just gives us a much more refined and scientifically sound model of the actual risk. And this new probabilistic thinking isn't just some academic exercise. No, it has led to the most obvious and immediate change in the entire code, a completely redrawn seismic hazard map for the whole country. And here it is. Take a look. The first thing you'll probably notice is that the boundaries have shifted all over the place. But the biggest news, the real structural change, is this. We've gone from 5 seismic zones to 6. This isn't just for show. It reflects a much more detailed, data-driven understanding of seismic hazard across India. And this is the headline change. Meet Zone 6. This is an entirely new, highest-risk classification that's reserved for areas with the most severe seismic potential. And make no mistake about it, the introduction of this zone is going to have massive implications for the cost, the design, and even the feasibility of any project that falls within its boundaries. Now, this is where the rubber really hits the road. Just look at cities like Worki, Shimla, and Shillong. They've all been bumped up from Zone 5 to the new Zone 6. Their zone factor, that z-value we all use, has jumped to a whopping 0.75. That is a huge increase in your design-based shear, right from the get-go. And even cities like Delhi, which stay in Zone 4, now have a higher, newly codified z-factor of 0.35. Okay, so the code has redefined the big picture hazard, but it also gets a lot more specific, right down to the project level. And the next major update is all about how we account for local grounds conditions. You've heard it before, and now it's truer than ever. It really is all about the soil. The concept of site class is now front and center. From now on, every single site has to be classified from A to D, and it's based on the shear wave velocity, the VS value, of the top 30 meters of soil. This is now a critical input parameter. Let me be clear, the days of just assuming medium soil for a preliminary design are over. A proper geotechnical investigation to nail down that site-specific VS value is now absolutely mandatory for an accurate analysis. And here's exactly why that matters so much. The new code gives us different response spectra for different site classes. Just look at the curves for site class A/B versus C versus D. See how they have different shapes? And, more importantly, different corner periods. This means the seismic demand on your structure is now directly customized to the specific soil profile at your location. It's a much, much more precise approach than we had before. So we've got our macro-level hazard, and we have our site-specific response. Now let's look at how all of this funnels into the nuts and bolts of our daily work. You know, the analysis, the load combinations, and the member design. Now this is a real game changer for our day-to-day calculations. The new load combinations now mandate that we include the vertical earthquake component, ELZ. For a long time, this was often ignored for many common structures. Well, not anymore. It has to be considered in combination with the horizontal forces. And that is going to directly impact your design for columns under uplift, your foundations, and especially any long-span beams and cantilevers. Here's another massive change, and this one directly expands our scope of work. It's the introduction of AEUs, that's architectural elements and utilities. For the very first time, the code is explicitly holding us, the structural engineers, responsible for the seismic performance of non-structural components. We're talking about designing connections and supports for everything from cladding and partitions to critical piping and HVAC systems. Our job isn't just about preventing a structural collapse anymore. It's about making sure the building is still functional and safe for life after an earthquake. Okay, I know that was a lot of information, so let's boil it all down into a practical action plan. Seriously, this should be your new go-to checklist for every single project you start, from this point forward under the 2025 code. It's a simple 5-step process. Step 1, and don't skip this, check the new map to confirm your project's seismic zone. Step 2, you have to get the geotechnical data to figure out your site class. Step 3, use the right site class-dependent response spectrum in your analysis software. Step 4, apply the new load combinations, and make sure you include that vertical earthquake component. And finally, Step 5, you need to identify and design those critical non-structural elements, the AEUs. So, to wrap it all up, here are the 5 biggest takeaways you absolutely need to remember. 1. The hazard assessment is now probabilistic. 2. We have a new, very high-risk Zone 6. 3. The soil at your specific site is now a critical input that drives your response spectra. 4. The vertical component of an earthquake is mandatory in your designs. And 5. Our design responsibility has officially grown to include non-structural elements. So, I'll just leave you with this final thought. This new code, it's not just a document. It's really a catalyst that's going to change our entire design process. It demands more rigor, it demands more data up front from our geotechnical teams, and it demands way more collaboration with architects and MEP engineers right from day one. So the real question for you to take back to your office is this: how will you and your team adapt your initial design phase to meet these new, more demanding, and ultimately much safer standards?